Labrīt! Labrīt, kolēģi!
Good morning, everyone, dear colleagues, because I'm sure that most of us can be regarded as colleagues since we share the same topic, at least one topic, namely, today we'll be discussing the use of modern technologies in surveying and researching cultural monuments. My name is Mūrniece. I represent the State Inspectorate for Heritage Protection of Latvia, and we are the hosts and organizers of this event in cooperation with the Norwegian Directorate for Cultural Heritage and also Ministry of Culture. And let me now give floor to Zanda Saulīte, who represents the Ministry of Culture and EU Structural Funds Department, to start off today's seminar. Thank you. Hello, dear participants, dear organizers, and also colleagues from the Norwegian Directorate for Cultural Heritage. And the Ministry of Culture for already 4 years has been implementing the Cultural and Natural Heritage Protection Program. And this year is very special for us because we will be closing the programs. And I'm really proud that we have managed to implement many great projects which are now appreciated by society as a whole, as well as by specialists and experts, both locally and internationally. And if we look at the implementation of the program, let me just mention 3 main qualities without which it wouldn't be possible to achieve such great results. Namely, the understanding and knowledge about the cultural heritage, as well as the skills to protect and conserve the heritage. And these qualities are really important when we discussed initially whether we are in a good position to achieve the set goals and whether we manage to do so. Because the understanding, knowledge and skills, these are the qualities that are mentioned basically in every project that we implement in the area of cultural heritage protection. And due to these qualities, we are able to really give our contribution in, for example, renovating the several wooden synagogues and other buildings that were covered under these projects that we implemented. And also, due to these 3 qualities, we have applied authentic and high-quality methodology when renovating these items of heritage. And last year we also organized several site visits to Norway, and in small towns we witnessed very enthusiastic people who are really interested in protecting and maintaining their cultural and historic heritage. And we also visited Niku Center in Oslo, where we saw how modern technologies are used in protecting historic heritage. And why am I talking about all these experiences? It's because cultural heritage is a resource that helps us to live a sustainable life, and this is something that let us know that heritage is not just about the past, but it's also about our understanding of it today and also tomorrow. So I would like to thank the hosts, namely the State Inspectorate for Heritage Protection and also our foreign co-organizers, and I wish all the participants of today's and tomorrow's seminar to have fruitful discussions on the cultural heritage. Thank you. Thank you very much, Zanda. Let me just once again remind you that this seminar is supported by the EEA grants and Norwegian instrument, and therefore we have a very great cooperation with the Directorate for Cultural Heritage of Norway, which has been really inspirational to us and very pleasant to us. And we have learned a lot from our colleagues from Norway, and I truly hope that we also have contributed to their work. And therefore it is my great pleasure to give floor to a representative of the Directorate for Cultural Heritage of Norway, Noel Dahl Poppe.
Thank you. Dear colleagues, dear experts, and dear friends. My name is Noel Dahl Poppe. I'm a project manager for the EEA and Norway grants at the Directorate for Cultural Heritage, or Riksantikvaren, as we call ourselves in Norway. The relationship between the state inspection and the Riksantikvaren goes way back. And it's always a pleasure to cooperate with the state inspection. We always learn new things from you. And the seminar today is a follow-up of a seminar that we held last year at the Open Air Museum in Riga in cooperation with the state inspection. It was so popular that we wanted to organize another event. So the state inspection suggested the topic of practical use of 3D scanning and new technologies. At Riksantikvaren, we were a bit surprised at first about this topic, but then we realized that we had very little experience in this field. So this was a good opportunity for us to enhance our skills. We introduced the idea to our colleagues, and the response was overwhelming. So today we are 9 representatives from the Directorate for Cultural Heritage. And we represent different interests and skills. The photo department, the Department for Information Technology, a project manager for digitalization of historical archives, and the representative from the archaeologist from the conservation department. So the views from all these different fields will shed light on today's topic from many angles. And together with the views from the expert and the international experience, you, all of you, we are hoping to elaborate the topic in depth and take a lot of experience and knowledge back home. So thank you very much for giving us this opportunity. So it is with great pleasure that we are participating at this bilateral event, as we call it in the EEA grants perspective. This seminar is, like Baiba said, financed by the EEA and Norway grants. And like Sanda pointed out, Latvia has run a successful program on cultural heritage under these grants. And the Riksantikvaren had the pleasure of contributing as a program partner. We have seen many good projects in Latvia, in Resekne, in Kuldiga, in Cesis, amongst others. And 8 out of 10 projects had a Norwegian partner. And this clearly points out the good relations between the cultural heritage sectors in Latvia and Norway. The reason why Riksantikvaren engage in international projects is that we believe that cooperation can contribute to tackle common challenges. So we are so pleased to see representatives not only from Latvia and Norway here, but also from Lithuania and from Poland, as one of our speakers is from Poland. or a speaker representing Norway, but he is from Poland. Cultural cooperation creates new opportunities and shared experiences. And the best results are obtained in cooperation with others. Good luck for today. Thank you.
Paldies, Noel.
Thank you, Noelle, very much. I'm really convinced that today's seminar will be successful. But of course, we can never stop and become self-complacent. We always have to move forward and look into the future, even if this area of cultural heritage seems to be mainly related to the past. And now it is my pleasure to give the floor to the head of the State Inspectorate for Heritage Protection, Juris Dambis. Ladies and gentlemen, dear colleagues, it is a great pleasure for me to kick off this seminar with the first presentation, where I will probably provide you a general insight on our today's topic. And if we talk about cooperation with our Norwegian colleagues, so basically, whenever something good happens in protecting of cultural heritage, it means that Norwegians are somehow involved. So we are really happy to have such great partners, and we have gained valuable experience from them. And what concerns the projects that we have jointly implemented, they always focus on quality rather than quantity. So, why we chose today's seminar's topic? Basically, we can see that we increasingly witness changes in how we organize the protection of cultural heritage, and with time we can see that the scope of our work is increasing. We are applying increasingly innovative methods. We involve a wider scope of specialists, and we somehow link the protection of heritage with the quality of human life. We no longer rely on one single absolute truth. And if we look at the Convention on the Societal Value of Cultural Heritage Convention, and how it defines the cultural heritage, it's no longer just the area of expertise for the specialists, but rather something that becomes more popular, which has close links with the general population, and it is also reflected in this definition, which means that it's no longer owned by just a narrow circle of specialists or otherwise, but rather encompasses the environment and also experiences of the people. Namely, this is something that we value, And what concerns the protection of cultural heritage, if we look at Riga Charter on authenticity, the protection is defined as efforts to understand, to research the cultural heritage, to protect it, to conserve it while learning about it. And if we look at specific sites in Latvia, altogether we have almost 9,000 such sites. Archaeology accounts for 1/3 or 29% of the total amount. Architecture accounts for 40%. And maybe this is the most challenging area, because the maintenance of architectural sites is quite it requires a lot of resources and efforts, and it has its own specifics, its own challenges. What concerns for example, urban areas or otherwise, they account for 0.5%. They, of course, also require a different approach, and they have their own specifics. What about art? You can see that it accounts also for 29%. It includes interiors, different ornaments, which also require daily maintenance and specific approach, not only to maintenance but also documenting and surveying, etc. What concerns historical sites, currently it accounts only for 1.5% of the over total number of cultural heritage sites in Latvia. Of course, history has always been closely linked with politics, especially during the Soviet times, and it has left its impact on how it is dealt with also nowadays. But finally, of course, also the industrial heritage has its own role, and it accounts for 0.2%. Sometimes these are quite sophisticated structures and facilities, and it's very important in certain cases to maintain their functionality as well. It is clear that cultural heritage is vulnerable. Each day we lose some of the heritage. However, of course, we try to include them in the different lists of the cultural heritage that has to be protected. But of course, we also follow the trends globally and at European level. And nowadays, also some unorthodox items are being included in these lists of cultural heritage. And sometimes they are quite controversial. But it is clear that cultural heritage requires quite a scrutiny, quite scrupulous work. But it's all, of course, is based on research, on documentation, as well as professional surveying of the cultural heritage, because surveying is the very foundation of conservation. Because if we haven't done the homework, namely the research and making of records, then we are at risk of destroying this heritage. And here we can see examples of how cultural heritage was documented several hundred years ago. You can see that the system was quite simple compared to today's systems. Here you can see a photograph, which is rather good quality photo, I must admit. But of course, this very brief description and photograph does not provide us with all the information that we would require in order to ensure preservation of this monument of culture. And when we survey, when we document these sites of cultural heritage, of course, we also rely on these historic documents. But of course, not always the measurements that we make are very precise, especially if we rely on the traditional methods. For example, like here, I can use very simple tool which measures with the precision of up to 1 millimeter, but it's not always possible to use these traditional tools, and not always they are sufficiently precise.
If we look back to those documents and those methods of fixation, those methods which we see there, so documents which we have in the archives of the inspectorate and also in archives of other countries, then we see that these pictures are rather precise, detailed, and they are also performed with speed, precision. They were performed being time-consuming, really nice facades, and also here we see that this author of the fixation have explored this object, understood this object, and also interpreted a little bit. And if we compare with the situation in the nature, so maybe it is not really like that, and so the object will not correspond 100% to the drawing. Here, one chimney, which is also reflected, so it is crosscuts, so the spatial picture, and it is very important to understand the values. But also the documentation is not so precise and not so detailed as it is possible to perform today by technologies. So cross-sections, drawings, all these materials are very important. It is really needed for preservation of values. We can see how the experts have done this in some time ago. So, and if we see in archives how much work has been done to have documents for all these buildings, and we always see, or already we can say that today's technologies provide us with other opportunities. They let us to be more precise. Now here, for instance, building in the neighboring street, so the three brothers around the 50s. And if we look at this black work, so to say, with this measurement, the material for measuring, we see in how many places experts have performed measuring with not so precise instruments and tools which we have today. So they have used rather elementary methods, and here we see that really the energy and time which they have devoted to perform fixation of this monument. And also here we see that this material doesn't provide us with all the necessary information which we would need in future to renovate such property. If we compare iconographic materials. If we look at this, we'll look at the Riga Historical Center, the panoramic view. And we compare them with today's situations, and we see that the person has applied emotions, so emphasize something, and proportions are not really true, and so they do not reflect the real situation, and thus the work is of course good and well performed, but we do not receive proper information. For renovation of cultural heritage, each detail is very significant. So it is significant for creating the image and also the atmosphere. Therefore, this fixation of values should be really precise and comprehensive. And here we can use modern technologies more and more. So the essence of preservation of heritage requires to observe the use of traditional materials, so the work methods for renovation, to understand the values, reasons for damages, this all on the basis of long-term work. But of course we have to observe that modern technologies already today provide us real opportunities to survey the values, document these values, and so our work quality can be higher and more productive. But of course we have to understand that the modern technologies have created also threat to our cultural heritage. We know the black archaeologists, and so we have to use future technologies and have to be one step ahead of all those who use these technologies for destructive activities. And I do hope that in future technologies will develop further and further, and we will be able to use them for our goals, and we will have more and more opportunities to gather very high quality information, and we will be able to document it, and this information will be a basis for more and better understanding of all this information. So through knowledge of these values we can acquire a lot, and we can renovate, and we can preserve our cultural heritage. I wish you success. I wish success to all experts who are working in this sphere, who use and apply these modern technologies, and I wish you also productive day today. Thank you. Thank you. And now we will speak about technologies, and I would like to remind that today we are listening here, we are learning. Questions and discussion will be afterwards in the afternoon. Right now we just listen to presentations, we put down our questions, and I would like to remind that tomorrow in the neighboring yard we are going to try and test the technologies. So Reinis Stačalovskis will show us how these tools really work, and so now he will tell us about the practice. Hello, I'm so happy to be here today, especially I'm happy to see our Norwegian friends here. I'm really happy to see you all here. I'm Reinis Stačalovskis. We are one of the companies here in Latvia that offer different services with 3D surveying, documenting and data analysis. And today I would like to tell you and show you what we could offer and how it looks like. So it will be rather theoretical, and tomorrow we will have practical work and also data analysis we will have tomorrow. So today I will show you conceptually, and tomorrow for those who will have interest so about technologies which we apply in our work and what we can offer, we will show, and you will also be able to have this scanner in your hands and try to use this and analyze the data. So one of the main principles why we do that and why we offer this service, not only for preserving this, the more qualitative is preparatory work, the better we can perform all scanning and prepare this material afterwards. And this means that we can save time and also money. And this is the universal formula which is used everywhere. The higher quality is the project, the better and the lower costs you have. So this is how we are doing and working. Before we continue, I would like to show you a video. I hope it will be good quality to understand for you who haven't seen this in real life. So what is the 3D scanner and how it works?
Laser scanner. We're at Schloss Favoridta in Ludwigsburg, the castle built in 1717 by the Duke of Württemberg. Our task is to fully document this Baroque royal palace in 3 dimensions. The building is characterized by, among other things, a variety of sculptures integrated in the facade, as well as richness of detail in the design of the roof. With conventional methods, it would take a lot of effort to measure this building. The new Ferro Focus 3D laser scanner is the ideal tool for solving such complex measurement tasks. The measuring instrument creates photorealistic, 3-dimensional images of real-world objects. The rotating laser of the scanner surveys touches, in the truest sense of the word, its surroundings. The laser beam is used to measure the distance to the object and, together with the device's rotation angle data, determines the coordinates in space. Several million of such 3D coordinates result in a complete 3-dimensional impression of the surroundings. But the Ferro laser scanner is more than just a professional measuring instrument. In addition to its compact dimensions, easy transportation and setup, it's characterized by a very intuitive and easy-to-understand operating concept. The integrated digital camera also takes photorealistic color scans.
Nu, lūk, es ceru, ka radās.
So I see, now I hope that you have some small insight how the laser scanner is performing its activity, and so we can come back to this presentation. So I would like to show how it looks afterwards. On the left side we have the object. So if you have classical methods, then you have rather tricky to measure. So here we see 3D measurement, and afterwards here we have made a 3D model. And then there are very many examples where 3D scanning has been applied. So here locally in Latvia, starting with very ordinary things, with heat insulation of buildings, with the same 3 brothers which were mentioned. So these are also... And also we had, not so long time ago, we had not really a dispute, but so let's say the discussion regarding what's going on with one object, and this object is Riga's circus, and the State Construction Inspectorate prohibited to use this building, and then they closed it, and then it was discussion what's going on with that building, is it really safe or it is not safe, and so what to do with that And so we performed 3D measurement, and we proved what's going on with that building. And here we have a detailed description and the final result. And I would like to tell what we did. What we did when we measured the building of Riga Circus. So here we have scanned the building with the facade, with the all interior, with the dome, with everything, with the part where circus performances are organized. So we have this 3 dimension, we have access, and we saw that the building and the dome is safe. So geometry has not changed. Everything is where it should be in their places, with the exception of the facade. So there you see the cross sections of the facade, and here, so we have so these cross sections every some meters, and so we here see these cross sections, and we can determine the condition of the building in those places. And so, and here we see that in the central part of the building, so the building is a little bit leaning towards the facade, but now we do not have any questions. What do we do with that building in future? So here also in color the pictures. The idea is that in the program we can ask to show where are these deviations from the vertical axis, and so with the green color, so the points are vertical towards or against the building, and with red color, so this building is leaning towards one part, and the blue so leaning towards the other part. So one more example where you can see it even better. So also here we have a building, so the district of buildings, and so also we have examined different buildings, and we can understand what's going on with that building. Besides, if such measurement is performed repeatedly, regularly, then we also can compare the results of previous measurings and see and tell whether these fluctuations or leaning is continuing, or whether this building is deforming, or it is standing still and it is as it is, and no problem with that will be encountered in future. Of course, when all this is scanned, then it is possible to have a 3D modeling, and so we see how it looks in nature, and then any restoration, any project related with that space, so all volumes are clear, everything is clear. We know which technical solutions should be applied, and also here in Old Town, when something is being built, we scan the object, and we understand that actually it is not possible to do like the project, the design is made, because according to our measurements it is impossible, and construction is stopped because the project cannot be implemented. So this 3D scanning actually really provides us with opportunities to determine the real situation of the building. And if we continue, so one thing is that we have acquired overall view, but we have also details here. So it is one example in the cemetery, in where we have. So at the entrance we have such a monument, and what result can you acquire here? So you see all the damages, and here we see that the nose has collapsed. If we have some photos or from many years ago, so what the program can do is that we can have the photo under this 3D measurement drawing, so we have the same perspective and see, and so the model have the modeling, and we see how it has been before. So any future artistic approach in restoration. So here it is, you will not amend or not change the previous image, so we can put together all the data, all the details, and we can have very, very precise and detailed geometric view. One more which I would like to show you, it's about urban planning. So it is for new projects, so new desires when we plan new urban places. So here it is very good example. It is Jurmala city where we have scanned block of buildings, and we have. So we can have here the existing topography and understand what and how everything is organized, where communications, where trees have disappeared, or maybe topography is different from that in real life, because right now any architect, any developer is basing all ideas on topography.
But nowadays, not always we can only rely on topography, and therefore this is a very great method actually to find out more about the real situation. And also this 3D surveying also allows you to actually look at your designs and how they will merge in the existing environment, because all the developers logically want to maximize their profits from their investment. Therefore, it's only logical that developers are always willing to show these visualizations from their point of view, not from ours. However, our technologies allow us to actually provide unbiased information, and these models can be viewed from different points of view, from bird's view, from left, from right, or otherwise, and it is really very clear how it will look after the project is implemented. And one of the most recent technologies that we are also using is these drones, or unmanned aerial vehicles, and they allow us to actually access areas that otherwise would be nearly impossible to access, especially this is a very popular approach whenever we need to acquire data on roofs of buildings. Then we can compare them with data acquired on ground. And here you can see some aerial photographs taken from drones. And if you allow me just to continue for 5 more minutes, let me just show you one more piece of technology that we use in our work, which I think also is a good illustration of how new technologies can be used in preserving heritage. Namely, these are so-called georadars. And these georadars were actually designed to map different utility lines and pipelines. And here you can see in red lines the utility lines that were not included in the topography. Here you can see 2 connections that had been built some time ago, and we also see one pipeline that has been in the ground from 1950s. Here is another example in the old town Riga, where a hotel is being built. And also here, with an unintrusive method, before commencing of the building works, we were able to survey the area. And here, without any digging, we were able to determine where are the old foundations of the buildings, somewhere underground. And here in green, we have marked the ancient city wall, which basically should be protected. And then we passed on this information to the engineers, and then they were able to actually map the pile driving activities so that they do not bother these or disturb these protected parts of old city wall. So first of all, we were able to protect them from pile driving and also from other activities throughout the building process. And as soon as the builders have this information, they are in a very good position to actually select the right tips for drilling and also pile driving, thus minimizing the risks of actually damaging these old walls with vibration. So this is what we do, and these are the methods that we are constantly improving in our work. Here is another example of a large-scale project, namely a tram line, which has been a quite controversial topic because it will go through or near old cemetery, and it is very important for the developer to determine whether these old burials would be disturbed by the construction of the tram line. And this is another example of the use of georadar, which allowed us to actually determine what's underground and whether these burials would be disturbed. Of course, there are very many urban legends, you know, whether there are people buried in this or that area of the city, but with this non-intrusive method, we actually provide facts instead of urban legends. So basically that would be an overview of what we do and what methods we use. And let me just once again remind you that tomorrow we will have practical demonstration. You will also see how data is collected. You will be able to actually hold in your hands this 3D scanner. We will also have a 3D printer, locally produced, by the way. So we will be able to print out some details, probably. And if you have some immediate questions, then you are welcome. Otherwise, we may discuss it afterwards. So, you mentioned that this Riga Circus building was originally perfectly straight. There were no deviations from the vertical axis. Or in other words, you took as the point of reference the original state of the circus building, but you can never be sure how it looked or how at what state it was commissioned more than 100 years ago. So actually we don't have a comparison. How do we know how much it has been leaning towards one side or other? First of all, let me say that if the builders 100 years ago were able to actually build a perfect dome, I think that also they would be able to build a perfectly vertical facade. And in this case, we acquired so-called raw data right after scanning, and I will demonstrate it to you tomorrow when we will have this practical demonstration. Whenever you use this 3D scanner, do you also take into account some geometric deviations due to the positioning of the 3D scanner? Basically, across the world, regulations are being adopted on how 3D scanning should be performed. Because basically, 3D scanning is just another way of surveying. It's quite similar to the traditional methods, and it also relies on certain guidelines. And currently, I must admit that in our legislation we don't have such very strict guidelines, but what we observe is the best practices. We closely follow the development of this area globally and try to adhere to these best practices across Europe. For example, the laser scanner provides us with data from a distance of up to 300 meters, but in practice we never use distances farther away from 30 meters. This is how we ensure the precision. And in practice, there have been many cases where there are some failures to acquire precise data. I'm not claiming that we are the only ones who do it correctly and most precisely, but my aim is to actually create an association of 3D surveyors so that we can rely on the methods that they use. For example, if we use the laser scanner and also this geodesic radar, you said that the dome in the circus building is practically perfect, but this data actually doesn't provide any information about the materials from which it is built. So even if it's geometrically perfect, it's not always safe because maybe the wooden parts are rotten. Yes, we are just talking about one of the ways of how we can acquire geometric information. Of course, 3D scanner is something new. It's definitely not a magic wand that will substitute lab results and control drilling, etc. And what concerns the geo radar, there are certain limitations to what extent it can be used and applied in each case. For example, the georadar works like that. It scans what's beneath it. So quite often we are approached by owners of buildings and they want us to actually determine whether there are some piles underground in certain areas, and we are actually unable to help them because if we cannot place this radar right above the area to be inspected, it's not possible because it doesn't work from an angle. So there are certain limitations to these technologies. Yes, what concerns the damages, you also mentioned some damages on sculptures and also remodeling based on the original photographs. So how precisely can you reconstruct these damaged parts? Of course, each tool has its own degree of precision. Currently, the most precise tool at our disposal allows us to measure with the precision of 10 microns. And for example, this wooden part has been scanned with 40 micron precision. Of course, during the modeling, some of the precision is lost, of course, because we cannot work with the 10 microns. So there is a certain degree of approximation. However, for example, in case of this wooden part, which we were commissioned to scan and to model for the purposes of restoration, here we went up to 100 microns. Then it is put on this molding device in order to shape actually this detail. Then of course it all depends on what tools are used to actually produce this item. Any other questions? So thank you very much for also sticking to the time. Oh yes, we have one more question here. Yes, I just wanted to ask about obstructions. For example, do you have cases where some trees or structures are in the way of these scanners? Because sometimes we have to work in very narrow streets or where the area is quite tight. But of course, yes, these limitations depend on what is our task and what we want to achieve, because technically each tool set has its own specification and scope of application. Currently we have the largest scope of tools in the Baltics, and the minimum distance for scanning with the handheld scanner would be 30 centimeters. With stationary laser scanners, the minimum distance would be 1.5 meters. So based on each situation, we apply the most appropriate tool or scanner, and also try to place it in a position that allows us to collect as much data as possible. Likewise, we perform also laser tracking or some other auxiliary measurements, because of course in each case we apply the most appropriate solutions. Sometimes it may of course create additional costs and also be time consuming, but basically most of the tasks can be performed. Yes, could you just very briefly tell us about how you interpret the data? For example, if you scan an interior which has been repainted for several times, so how do you determine the materials to be used afterwards by the architect? Yes, the main thing is what's the data that you want to acquire. If you want the data for restoration works, and for example, we are looking at the frame of a picture, the methods of surveying and measuring are quite different. And if we have 3D point cloud, then from this cloud I extract the information that I need as a restoration expert. And therefore, I no longer have to visit several times this site, because from the cloud I can gather all the points, all the measurements that I need. Of course, not always it is a universal solution to scan it and then model everything. First of all, we acquire 3D measurements, and unlike geodesic approach where they have XYZ coordinates, with laser scanner within 1 second we gather almost 1 million points in space. And afterwards, of course, everything depends on your capacity to use this data and also the specific task or objective that you want to accomplish. And some 20 years ago, architects just still worked with drawing boards. Some 15 years ago, they started to use AutoCAD and other computer-aided tools. Currently, we are switching from 2D surveying to 3D surveying, and this trend can be observed not only across Europe but also in other parts of the world. So basically, Scandinavia is also among the leading countries in using 3D technologies in the construction sector. So it's just a question of a couple of years before we are fully converted from 2D to 3D.
I would be able to answer your question about wooden structures and the damages. So that is not the technology which was mentioned here. It is possible to do if there is some rotten part and some log. So there are devices or tools with which we can determine the density and compare just not damaged and damaged structure. We see the damaged parts, and so it is possible to do so. But it's another technology, another tools to be applied. So one more question. So the question is as follows. How deep burials can you examine and survey, so for how many centuries or so? How precise can it be done? So because it's quite a lot of work to do also in future. So technologies which we have today so allows us to have information down to 5 meters in depth. So of course geo-radars are slightly more complicated than laser scanners because data which we receive from geo-radars classically look like this. So the computer is slow, but okay, here. So here's a picture. So classically, so I don't see, it's not so well visible, but on computer it is better. So this is a classical example which we can show. So here we have the data of drills, and the geologists have made the lines, and so here with GeoRadar we receive such data, and in any case, so the data are to be interpreted easier if they are received from GeoRadar. And what we can do here, so we find similar data in one place and another place, but it's always a risk that we can also miss the data. So that is the technology of GeoRadar. So I will not tell how it all works, but I think that tomorrow we can show that in real life. It will be easier to understand. Thanks to Reinis. So Reinis will come also in the afternoon for discussion. And I also looking forward to tomorrow's morning in the yard of Three Brothers. So we will see how it will look like, but it will be very interesting to try all this. But now we will have the next speaker, building engineer Aldis Grasmanis, who has worked with one of the main vertical dominants of Riga, so Riga Cathedral or Dome Cathedral, and he has lots to tell us. Hello. I'm really pleased to be here in today's seminar and tell about my experience. I see many familiar faces and I'm also honored to see here my Norwegian colleagues, and I will be happy to tell about my experience. So my name is Aldis Grasmanis, and I will tell about one specific object, about the experience with 3D scanning in that object, and I would also say that this experience is already historical, so to say. Since technology is new, and of course technology is developed, and what I heard, what Reinis was telling, so possibilities we have better and better year by year, and in 1 year's time he will be able to speak about other opportunities provided by 3D scanning. But my experience is from 2013 and 2014, when we performed 2 projects, or on 2 stages we were developing a project for Dome Cathedral, and in fact these opportunities at that time, so some years ago, so now I told what I heard, what Reinis was telling, so that we didn't have so much of these opportunities. Taking into account that the object is really significant, it is one of the most significant objects, historical heritage objects here in Latvia and in Latvia. So a real short history about the Dome Cathedral, Dome Church, and here just to understand what we were doing and what is that object, and taking into account that we have Norwegian colleagues here, so just a short insight in this. So 2000, oh sorry, so wrong figure here. So 1,200, so to say, yeah. Oh, sorry. And so more than 800 years ago, they laid the foundation stone for Dome Cathedral. Yeah, you see, presentations also sometimes have mistakes. So when you will leave this building, you will look at the Dome Cathedral, and you will see that it looks slightly, not really similar, but more or less the same. So this was first made by architect Neimans. It looked like reconstructed by architect Neimans in 13,000, so it was 1300, so it was the same almost. Then from it was the church changed from one volume church into basilica, and then the tower was erected. So we will see that in the cross sections of the tower. And what is very important, 16th century, we see the big fire, and the church burns down, and the tower is built anew. And what is very interesting is that the Dome Cathedral at that time, and for all those years, it was like a competition between the Dome Church and St. Peter's Church, also regarding the height of the tower. And so these towers are built very high due to that competition among the 2 churches. According to the date, in the 17th century, the tower of St. Peter's Church collapses, and there is real doubt regarding the structure of this, and safety of the tower of Dome Church, and it is surveyed, and according to the decision of Riga Council, it is demolished. And what is interesting is that they retain the wooden structures here, because that is the load-bearing part of the tower. And here this structure is retained from the previous reconstruction since the 16th century. And here in the 18th century, the lower part of the dome is built, and also the upper dome is built. And here we see that the tower is already seen, and so we see it as it is today, and it is from the 18th century. So the picture here, what is being used here, it is prepared by AIGA. So I see also Arturs, representative of this company, who prepares the drawing. And here we see very well the survey regarding how this tower has been developed through ages and how the brick walls were built. In the 19th century, the most essential things that were done are mentioned here. So the main entrance portal is built, and also the organ of Dome Church is erected, and installed here, and they are the largest in the world. And so actually we can't even imagine the Dome Cathedral without the organ. And what is very important also, until the 1914, the Dome Church is being reconstructed, renovated, and it is as we see it right now. The last century, or 20th century, is remarkable with different technical reconstructive moments. So we have engineering systems, reconstruction of the organ. What we see, they also see the perimeter on the level as it was historically. And also, during the last years, we have renovated the facade, and the roof has been replaced. And what we did was we reconstructed and strengthened the wooden structures of the tower. So the project was developed on two stages. The first was the principal solutions regarding the very tower, and the second part was the detailing of the project solutions, so for restoration, for the solutions which were developed. So during the first stage, we paid more attention to the very tower, to these wooden structures. We performed 3D scanning to the wooden structures. And so to have visual understanding of this, so these wooden structures, as we see here, they are rather complicated and spatially dense, so to say, and that created difficulties for scanning. As Reines already mentioned, for such complicated objects, we have additional requirements for scanning and the way how the work is to be performed. First of all, with the help of geodesic instruments, we had some reference points with precision of half a centimeter. I think it was just some millimeters for those points, and then we applied the scanner, and we scanned every room, every part of this space. It is impossible to have all in at one go, because we have then this shadow principle, and the minimum number of the points were 3 on each floor. And then these scanning data were merged in one model. So for some time ago, we worked with this afterwards manually, but now I know that the soft is available, and so they are examining and doing everything with that cloud of points, and you can have the model, and so you can use soft. But we did this manually with AutoCAD. So these lines were made by using the cross sections of the model. What else? So what we acquired? We acquired from that model. First of all, we found what was already mentioned before. So the model was we could use for all next generations at any point of time. So you can have additional data by measuring, by having cross sections, looking at this from different angles, so performing surveying work with the model. But our main task was to examine, to survey the structures of the very tower. And we have the model, and we acquired very interesting information, since we saw that this leaning from the vertical is approximately 62 centimeters. At the same time, that was for brick walls, but for wooden structure it was vertical. And that allowed us to conclude that the deformation of the brick wall has been has happened for a rather long time, and already and this wooden structure has stayed vertical, and this means that the last 300 years no essential deformation of the tower has been present. So, and that was one of the questions which we had to answer during the project, because we had a question whether we need to strengthen the foundation of the church. So the question was whether that is, how urgent that is, and how could it be performed. So deviation from the vertical, that was one thing, and another was the bending of the slabs. So it was approximately 20 centimeters, and that means that it is close to critical. And that meant that on the basis of these data, it was a decision passed to strengthen the whole core of the tower. Here we see how it looks, how the cross section looks from the point, from the cloud of points, yeah, and when we have applied AutoCAD, so when we make this in the software.
And when we talk about the advantages of the use of these technologies, first of all, I should mention the time savings, because instantly we can acquire a huge amount of data. And of course, we also studied the previous surveying, which was conducted between 1976 and 1979, which was quite detailed, especially in terms of coverage of the wooden structures, but it took them 3 years. And in comparison, we acquired all the information that we needed only within 1.5 months. So, obviously, nowadays, when time is money, it's crucial for us to have such time savings. And in the second stage, as I mentioned before, we paid more attention to details for the purposes of restoration. So we moved from the tower to the chapels that are nearby the tower, and we also cooperated with the company represented by the previous speaker, Smart Engineering, and here we can see one scan of the chapel. And here you can see it can be compared with the cross section. Here you can see how it mirrors the arches. And we also can see here that this scan is made in color, which also allows to acquire data about the colors used in the interior. And also we can see that more detailed information is obtained. Of course, here we can see the overall geometry, but take into account the complexity of the forms. The scan allows us to actually acquire all the measurements of all the details that we have. Basically, we acquire a digital copy of the real-life building. So that would be my experience in working on a dome cathedral. And I would say that without this scanning technologies, we wouldn't be able to do it manually within the set deadlines. And of course, so this technology not only allowed us to meet the deadlines, but also to acquire high quality, high precision data. So this is our positive experience with the 3D scanning. Let me just add that we also currently participate in the project dedicated to the TV tower, where we will also be using 3D scanners. And in this case, as previous speaker mentioned, we will be also using drones to carry these scanners, because of course in case of a TV tower it is practically impossible to do it from ground or otherwise, so it's only logical to use drones. So we will combine data acquired from ground, from various surfaces, but of course drones would provide us with more quality data. Unfortunately, some portions of the TV tower, they reflect the laser beams in a way that not always allows us to acquire high quality data. Therefore, we use a set of different tools to acquire all the necessary measurements. So thank you for your attention. Yes, thank you, Mr. Grasmanisen. Do we have any immediate questions? It seems like currently we don't have any, so let me ask my question. So what do you think, why we still some kind of reluctance among cultural heritage specialists to actually apply such new technologies? Do you have some experiences where customers were not quite satisfied or otherwise? Actually, in my experience, it all comes down to how you process the data that you acquire. And basically the quality of the final result strictly depends on how you use the data that you acquire. Of course, we can use AutoCAD and do it all manually. We just draw line by line, and by this we already in a way interpret the data. But basically, much depends on the specialist who works with the data. Of course, currently we have software that allows us to create automatically maps based on the data clouds. Secondly, of course, much depends on what is the task for which you are commissioned. Of course, there are countless technical possibilities to scan with the precision of a couple of microns. However, for example, in this case of church, we wouldn't be able to process the data if we used the precision of 10 microns or otherwise. So for each task, for each appointment, we select the best approach, and then of course we choose the most appropriate solution, whether we should focus on details or geometry or otherwise. So also the degree of precision depends on each particular task. Of course, there were also some details in the interior where we used really high precision measurements in order to obtain detailed measurements of specific items. So basically it depends on what is our task and what is the objective. Because of course it's a very technical thing that we do. Of course, some say that, you know, whenever you do it manually, you feel more connected to what you do, and probably this also echoes the whole atmosphere of historic heritage. But nevertheless, these technical innovations allow us to provide really precise input, and in many cases I seriously doubt whether the tasks that we do can be performed manually. But I think that the deviations or the interpretation would be much higher. And also it's about time saving. If we want to obtain all the details in manageable time, I have no idea how much time it would take to make the measurements manually in the projects that we have been involved in. So the question is, what you want to achieve? Yes, when we talk about the dome cathedral tower, the initial idea was to actually strengthen, reinforce the foundations, because otherwise there would be some risks, long-term risks. But based on your precise 3D measurements and surveying, did it really help to basically rescue the tower from large-scale reconstruction, since you determined that there is nothing wrong with the foundations? So do you think that you contributed to the preservation of the tower as it is? Yes, I think definitely it helped, because we concluded that, yes, the tower is leaning towards one side. It was even visually possible to determine, but after our surveying, we determined that it is this leaning has happened over a longer period of time, and it doesn't create any threats to the tower. The same goes with the foundations. Probably at some point in the future there will be a need to reinforce the foundations, because of course we have also measured different fractures in the walls, but basically it's not due to critical problems in the foundations. There are certain movements of certain parts of the building, and if we want this process to stop at one point, we would need to reinforce the foundations, because these deformations can be observed both in the exterior and interior. What concerns the reinforcement as such, and installation of additional supports, then actually, based on our surveying, it was determined that there is no need for such additional reinforcements and supports. So basically, we avoided introduction of additional elements to the building. So basically, yes, your measurements helped to preserve the building as it is. Thank you. Yes, I just wanted to ask you, since you have great experience and you have great portfolio and you have been working since 2013, and we had the privilege actually to visit the Dome Cathedral when you were working there. But what about future plans in this cathedral? Do you have any knowledge about future developments? Frankly speaking, of course, I don't have all the details about specific plans, but as I mentioned before, at one point in the future, there will be a need to think about the reinforcing of foundations. But based on our analysis, the defects or deformations are not as critical as they were thought to be. So I would say that the further construction works or reinforcement works are currently postponed, since there is no pressing need for them to be implemented right away. From the previous presentation, we saw that these three models can be used for various interpretations and cross-references with topographic data, etc. You, as an engineer, you said that a couple of years ago all this data was used also in AutoCAD. Do you think that nowadays also there could be some software that could be used for calculation of the measurements of wooden structures? Actually, we have discussed this issue in relation to the TV tower. But basically, after the scanning to model this 3D picture, it's just a picture. It's not data with specific measurements. So you can use it as geometric point of reference for calculating different cross-section, etc. But basically we are talking about a different set of data. So currently the technology has not developed so far that we could automatically use the software to make some measurements. So yes, thank you very much for your input, and thank you for the questions. So now we have a break, a lunch break, and we will return here at 1:30 Riga time. So please return some 10 to 15 minutes earlier so that you can have some snacks or coffee, but 1:30 we will return and resume our work. Thank you.